Hi everyone, like I promised in the demo video that you see a screenshot here, I want to show you and share with you 3 ways to distribute points inside the volume, overcoming the limitations that are currently in geometry nodes with this node. And today I want to focus on the sculpting shape. What do I mean by that? If you take a close look at this, this wall was medieval wall was created using the sculpt method, actually like a boolean approach, but with points. And I want to show you something else that I was working on. It's let me show you. If I go here, yeah, you can see now. This is another example. I made this circular tower with battlements and everything, and it looks quite nice. Everything it's actually done inside of geometry nodes. Well, of course, you have some objects instanced. So if we take a look here, this will be the node tree. It looks fairly complex, but everything is based on this grid. So if I cut this, everything goes away. And like I said, this will be kind of a Boolean approach. And by combining shapes, you can get this nice result. And also, I made a preset. And actually, this is what we are going to do together today. This preset gives you access to different Boolean operation, difference, exclusive OR, intersection, union, and also has this visualizer. So if I connect this visualizer to my final geometry, now we see nothing because we have to activate this instancing of real objects. And now I can see the two inputs, A and B, and I can even give them a color. So now I can easily see how to work with them. So if, for example, I am doing any changes here, I can see how the cutting operation will take place. It's really useful. For example, going to a previous step and going and looking at this, activating these two options. We can see how I made these cutouts that represent the windows that we see if we look at the final geometry. See these ones here. So let's try to recreate this together. We will need a few things first. We don't need the camera. We have already a starting geometry node. This is how my file is set up. It's a single vert with a geometry node on it. And in order to instance points, we need a face. It can be anything. So let's put inside here a grid like I did before. And now we have a face. It doesn't have to be a quad, it can be a triangle. we need a face, and that's it. So let's add the distribute point here, and now if we increase this, we have some points. Okay. So how can we get some basic shapes? Let's make a cube with distributed points inside of it. And the way to do this, we use an attribute randomize. Attribute randomize node, and we take a vector, and let's say position. And we start from 0 to 1. Now we have basically a cube. Let's do something about these points because they are to be big. Let's use an attribute fill and use their radius and make something a little less crazy. Okay, let's get some more points. Make like 1000 for now. So now we have a cube that has points distributed inside. We can take now the cube and make a sphere out of it. How can we do this? We need an attribute compare node. So we take this geometry and we take the position. Okay, let's put it here. Let's take the position and let's say we under result into a sphere. And we want to compare with a vector. We want to compare with the center of this object. So being in between 0 and 1, the center will be 0.5. And we want the equal operation. Why do we want this? It will give us this threshold that will be basically the radius of our circle, because the attribute compare will go like this. We'll compare the position with this value and we'll say, is this point here equal? Yes. Is this point equal? Yes. Is this point equal? Yes. And so on and so forth. And it will write the result in here. So now if we do a point separate and we use this as a mask, we can get our sphere by increasing the threshold. If we put it like 0.5, it's like half of the original size. Let's add some more points, like 2000. Okay. So basically now we have the cube. Let's call this cube. And we have, we have a sphere. Let's call this one sphere. And this is the base. By using the other two methods that I developed, you can combine with this sculpting and do some really cool stuff. But the focus is on doing the boolean stuff today. So how can we use this shape and this shape and do boolean operation with them? So we need a way to compare these shapes. So we're going to use attribute proximity, and we'll take, this will be the first shape, and the result of here, the sphere, will be the second shape. And we are interested in the distance. Don't forget to change these to points because we are comparing points. Let's call this cut point distance. So now This node will take the points generated in the shape of a cube with the points generated in the shape of a sphere. It will compare them, the distance between them, and we'll write it to this this attribute. If we take a look at the spreadsheet, we have this. Where are you? Oh, I have to connect it first. Yeah, of course. Otherwise, we can see it. So now, if we look, we have this distance between the points of this one, the cube, and the sphere. And the way you can use this, it's by using another attribute compare. And this will compare this value that we created, this distance, with a float, because this is a float value now. Let's say 0, and we'll create another attribute, cut points mask, because we are going to use another point separate. Let's change this one to equal, and let's do the point separate. And we plug in the mask, and voila, we've got our shape. And now if we take this sphere, let's call this one cutter. Okay, so if we take this sphere and we move it by transform. Okay, so we move this sphere and we check our shape. Let's move it like half a meter. And increase a little bit the threshold. Okay, now we can see something. This threshold is basically the tolerance between how far can we get from these values and still be considered as equal. So now we can see that if we move this one, we are basically have the cutter. This will be the first operation. We will call this one difference. A minus B. Yeah, and so we have this one. Before going further, I think it will be nice to make the cutter. No, let's finish these ones first, and then we'll do the cutter. Okay, so we have the difference. How can we get the union? Well, that one is a simple one. Join geometry. So let's call this one A, and let's call this one B. Okay, so if we take A and B and we join them, and we plug it here, we have the union. So we don't really need for now the viewer, but we can do this radius. No, let's leave it like this. So we can see now the shape when we are in join geometry, which is our union operation. Okay, we can see the shapes. And this is the union, this join geometry. It's basically the base for the viewer. Just it has a different radius for the shapes, so you can easily see, and has some materials added. So if we go back to difference, this is what we have. How can we make the exclusive OR operation or the intersection? Which one should we do first? Okay, the intersection. This one is the intersection. It's easy. The common part. Intersect. It's basically what's left by removing the two shapes. And the exclusive OR, it's a little bit different. We have to make this duplication and oops, instead of connecting the target DA to the geometry, we connect it to the target and the B to geometry. And now we have this one, but it's B minus A. This will be the opposite of this operation. A minus B, we cut the corner of the cube, the shape A. B minus A, we use the cube to cut into the sphere. And now we can do the exclusive OR operation, because that's another join between these two operations. So if we join this operation with this one, the result will be this, the exclusive OR operation. Let's call this one exclusive OR. So there you go. This is the basic of the boolean cutter. You get the union operation, meaning joining the shapes. You have the intersect operation, which is the rest between comparing these points. You have difference A minus B. You have difference B minus A. And you have the exclusive OR. And the way to build the visualizer, it's actually really simple. You just take the inputs. Let's steal this node first, and we duplicate it. And let's plug in the A and the B. And we'll leave this like this, and this one will make it a little bit bigger. So now if we scale these points, the radius, if we join, and we plug it here, see, we can more easily control the shapes, because now we have different size to the points. And if we want to make it like I did it in the demo, let's make a cube. It will be our base instance. Okay, going back to this one, let's add 2 slots. Let's make two materials. Let's call one red and the other one blue. And I'll do it like this. And this one will be like this, a red material. A very simple red material. And now let's instance points. Let's say point instance. Okay, and we want to use the cube. And we need a scale. Float. Make it like 0.02 like here. And we can use a scale here, different sizes. Now we have real geometry, and we have also control of the scale. And in order to add color, we use a material assign node, and we put one for blue and the other one for red. And if we switch now to material preview, and let's cut this. Okay, now we have the cutter visualizer, and the only thing left is to simply connect those two outputs, and it's done. So I will give you a screenshot how I connected everything to this node. This is the logic block. The attribute proximity, I use the cut points position also, even though it's not necessarily in this example, but you can use it for more complex stuff. I expose the threshold to allow me to control the fall off. I called it the B shape influence. And of course, I have the A shape, B shape exposed. The outputs are those that you saw connected to the output. And the visualizers, I added some switches that I show you at the beginning, allowing me to select if I want to make real objects needed for the materials, if I just want to instance something, or just see the points with different scales. So this will be the attribute fill for the radius, this will be the point scale for the A and B, and the materials for the instances. This is important to keep separate, because when you add materials, you make the instances real objects and can become really heavy on your system. So here you go. This is the entire stuff. I will show you again on my file here. The final node. I'll open this one so you can more easily see everything. It's pretty much everything. And I'll stop here. It's longer than I intended anyway. It's like 25 minutes and I wanted to do it in 15, but hey, work in progress. I'll learn how to make shorter tutorials. Anyway, thank you for sticking with me for this tutorial. Hope you learn something useful, and see you in a few days. I am planning on posting on Tuesday the second part. I'm showing how to distribute the points inside another method. Hope you'll see you then. Until then, have a nice day.